Hello, everyone. Thank you for joining us for another live webinar session hosted by EE Tech and All About Circuits. My name is Dale Wilson, and I'll be your moderator. Today's session is brought to you by Omron Electronic Components and is titled Unlocking Weather Insights with LoRa, Revolutionizing Weather Station Communication. Let me tell you about our presenter. Cary Horan attended the Georgia Institute of Technology, where he obtained his Bachelor of Science degree in Mechanical Engineering. He is currently the Business Development Manager for Omron Electronic Components, serving as America's technical contact for their diverse sensor product offerings. He has expertise in the manufacturing field, including IoT, healthcare, and agriculture applications. Following the presentation, we will have a live Q&A session with Cary, so stick around for that. You can submit your questions at any time during the webinar using the chat box on the right-hand side of your screen. We will provide all attendees with a downloadable copy of the presentation near the end of today's session. This will be available in the Resources tab, along with a few other helpful resources you can access at any point during the presentation. Thank you so much for joining us, and with that, I'll hand it off to Cary for today's presentations. Welcome, Cary.
Thank you very much. Hello, everybody. Good day, and welcome again to today's webinar presented by Omron, Unlocking Weather Insights with LoRa Technology. Again, my name is Cary Horan, Business Development Manager, and I've been with Omron for the past 5 years. We're very excited to share with you several of our insights into the LoRa space and how technology is affecting Omron innovation. We'll be talking about a number of things over this webinar. We'll start with an introduction into LoRa communication protocols. We'll talk a little bit about the industry effects towards several key industries and how LoRa is affecting tech advancements. We'll talk about some of Omron's own innovation into this field, and a brief look into the future and into some of Omron's other product offerings. So let's start with an introduction into LoRa communication. We'll start with a poll here. A poll question has popped up. This will be the first one of the webinar. But we'd like to know what is your familiarity or what are your goals with LoRa communication? Whether you're just now learning about LoRa and are curious about how it's going to be affecting your potential projects in the future, or if you're actively working to find a LoRa-based solution for your next project, we'd like to know about your goals and what your needs are. So what is LoRa communication? LoRa stands for Long Range Wireless Communication Technology. What makes this unique is that LoRa technology uses spread spectrum modulation, which allows for devices to transfer data across several different frequencies simultaneously. This allows not only for a much longer range compared to other communication protocols, but also allows different bandwidth data to be supported by LoRa networks. Whether low or high bandwidth data, you're going to have effective data communication using this technology. LoRaWAN is a commonly open standard for building IoT networks using LoRa technology. And we've seen over the past several years, LoRaWAN's expansion and LoRa in general having a much greater effect on various different industries in terms of managing their data. What's also unique about LoRa communication is that it enables, LoRa technology is that it enables bi-directional communication between devices. So not only are you having sensors that are able to collect the data, but central areas are able to send signals out to the sensors to affect performance based on conditions. As different industries have progressed, we've seen a lot of emphasis on the need for different forms of data collection and data management. With that, we've seen the rise in advancements of different technologies, especially in ways to make them more long-range, faster, and more effective. LoRa is becoming a much more ideal communication protocol for different applications such as in smart cities, agriculture, asset tracking, and industrial monitoring applications. So how has the market changed to reflect this? Market growth has been driven by the increasing demand for IoT connectivity solutions. As various different industries are looking for ways to better manage their data, we're looking into the IoT, Internet of Things network, to help build devices that are able to connect connect effectively and transmit data to users. We've seen, again, the rise of the LoRa WAN standardization that has played a pivotal role in fostering market growth by ensuring interoperability and the correct standards for data transmission. We've seen different standards that are erupting in various different industries, such as between energy or smart city or agriculture, based on the data that's being collected. But the growing standards for LoRa technology has made this a continually growing form of technology that will continue growth over the next few years. The number of LoRa-enabled devices that are on the market have witnessed significant growth, fueling the expansion of the built-in networks around the country. The current LoRa devices market sits at $5.6 billion, but is expected to reach $25.5 billion by 2028 with a 35.3% growth rate. That's a huge advancement forward for LoRa technology. And as this technology grows, so will various different industries that are going to want to take advantage of this new effective form of data transmission. Especially as technology is developing for rural areas, it's very important for applications in agriculture and oil and gas that will be looking towards LoRa devices for communication, especially as they're needing to transmit data over long ranges and across vast and unoccupied spaces. So for Omron, our project overview is looking over various different devices that are going to be very effective in the LoRa space and using Omron's own technology to best bring together these two very advanced applications and technology. One of the main projects we have is the Omron Weather Station, which we'll talk about in more detail later on in this presentation. But we'll keep this in mind as we go over the various different industries that are especially going to be affected by the growing advancements with LoRa technology. We have seen evaluation of our sensors through our own offices and with testing all across the US and various different countries. With the rise of LoRa as a long-distance, low-bandwidth form of communication, we can see the benefit for the LoRa station and our IoT module in many different industries. Our webinar will showcase the greater needs of LoRa communication in these various different industries and how we're specializing in addressing these needs. Up next, we'll talk about some of the industries that are being directly affected by the growing LoRa space. Before we get into it, we'd like to bring up our second poll question. What industry are you most closely working within? Over the next few slides, we're going to be talking about some of our key applications that we're focusing on, those being agriculture, oil and gas, and energy, and smart cities. But if there is another application that you're working with, we'd love to hear about that too, and seeing how LoRa technologies can influence your projects. So we'll start with agriculture. Day to day, there are a number of different obstacles that those in the agriculture sector are facing day to day. One of the biggest ones is, of course, agriculture being outdoor, the environmental problems that can affect the agriculture sector. Climate change is bringing about effects of drought and famine towards many different areas of the world. We've seen the droughts that are affected in California and the Western United States, as well as the famine that has been a result of that, the lowered crop yield. But that's something that is that affects agriculture sectors all over the world. So looking at devices that can effectively monitor crop health and potentially look at how well a crop can perform in various different climates is going to be important to maintain the best possible outcome for crops. The COVID-19 pandemic brings effects that we're still experiencing today, not only directly, but we're also seeing the indirect effects in terms of imports from supplies and parts that are able to properly maintain devices that are working on agriculture, working in farms and ag applications. The population change is also something that really affects the agriculture industry in a couple of different ways. The rising aging population unfortunately removes some people from the workforce, as well as the general growing population, which brings about a greater demand for higher crop volume. All of these are contributing to a demand for precision agriculture. And all that means is that we're looking at a newer form of farming that allows for devices to be implemented that can sense in real time the health of crops as they're experiencing the weather conditions throughout the year. By introducing LoRa into the agriculture sector, we can bring in a number of different advantages. Now, as we contribute directly to precision farming, of course, the biggest need there is data and maintaining that data over time. Excuse me. By introducing LoRa, we're introducing devices that are able to effectively and quickly collect data and communicate that over long distances. The long-range coverage is a big advantage in LoRa, as many agriculture applications are in remote areas where you're not going to have a lot of opportunities for that long-range communication. In these remote applications, low power sensors are going to be needed, as you're not always going to have a direct line to direct power. So you're looking for sensors that can potentially operate using greener energy, such as solar panels. And for that, you're going to be looking for devices that can run effectively in low power scenarios. LoRa offers that advantage in being able to work well in low power applications, being able to transmit data over a long distance, but with low bandwidth, and using that spread spectrum modulation to effectively maintain that data even in low energy applications. Lastly, the big advantage offered in scalability. As the IoT space continues to change and the agriculture sector continues to utilize devices over long periods of time, LoRa devices are able to adapt to the changing IoT space so that scalability can be achieved in the agriculture industry. Looking at energy, oil, and gas applications, the biggest obstacle that faces this industry is energy reform. Across the world, we're seeing an increased demand to switch to green energy, or at the very least, introduce devices that allow for smarter energy consumption. There is a need that is rising for smart devices in the home. There's a need that's arising for smart devices in the home, but also directly at the source of mining itself, so that we can ensure that, that energy is being mined safely and efficiently. Similar to agriculture applications, in energy and oil and gas, many of these applications are remote. So we're going to be looking for devices that can transmit data over long distances. And lastly, what's important for in any industry is worker safety. Keeping people safe who are working directly in these applications, as well as those in the surrounding area, is critical for applications to be working well. By introducing smarter devices and devices that are able to transmit data effectively, we can ensure that workers are able to know exactly the situation that they're entering and know if something is in need of more attention. By introducing LoRa, we bring in many different advantages, some similar to the agriculture industry. Remote monitoring and long-range coverage are especially important, as we're able to look at how devices are operating even from a distance. Looking towards low power sensing applications so that we're able to transmit that low bandwidth data over a long range and be able to get that data effectively in the hands of the right people. And then in oil and energy and gas, security and reliability are both critical. We're looking at very sensitive data and data that can affect a much larger portion of the population in terms of surrounding area, as well as the power that is being generated from these mining applications. By introducing LoRa, we can introduce devices that are effectively able to maintain this data and work along effectively with the obstacles that are facing this industry. Lastly, we want to look at the smart city applications. The biggest need in this industry is the need for interconnectivity between devices. In this industry, we have a number of different applications that are going to be working often in a singular urban area. We have different devices that are needed here to monitor various different data points: traffic, public transport, streetlights, utilities, as well as the environmental data, such as temperature, humidity, and the weather conditions in general around the city area. As we implement all of these devices, you're looking at a need for devices that can work together so that you can maximize your data output and the usability. With many devices that are implemented in a small area, we're looking for something that can be effective and low maintenance so that we can still capture all of the data that we're looking for without the need to constantly be monitoring how well they're performing. By introducing LoRa into the smart city industry, we're offering many different advantages here. Long-range coverage, again, over similar to our other two industries, we offer the ability for connecting devices over the entire space of a city. Interoperability with LoRa devices having two-way communication. We're able to incorporate devices that are able to work together in a singular network. And all of this contributes to an improved quality of life. This is especially important to Omron's principles to improve lives and contribute to a better society. However, in general, having LoRa incorporate into different industries to improve quality of life can be a common goal for all of us. So now let's talk a little bit about Omron innovation and how we're looking to design products in the future to better be equipped within the growing LoRa space. Our goals as a company is to connect data and to empower people through automation. This is something that we share across all divisions of Omron. But with device and module solutions, we're looking forward to developing devices that are better at connecting people and to help different projects run most efficiently. So with incorporating LoRa into our devices, we're going to be focusing on several different key benefits. First, looking at long-range communication, providing extended wireless communication range. We're looking at low power consumption to maximize energy usage. We're looking into cost-effective solutions, not only with infrastructure deployment, but also with ongoing maintenance over time. We're looking at scalability and being able to adapt to ever-evolving IoT application needs. And we're looking to employ devices that can have diverse applications, not only in the focus industries that we've talked about in this presentation here with smart cities, agriculture, and energy, but also in logistics, asset tracking, and general environment monitoring applications. Our foundational project that our engineers have been working on is the IoT Gateway module. These are communication modules which are going to be able to connect devices or sensors to the cloud wirelessly to send and receive data. Now, how this works is that Omron will be able to provide a customizable solution from various different communication modules. That means within your application, if you're looking for LoRa communication or cellular or wireless or Bluetooth, Omron engineers have experience with several different communication protocols so they can better equip you with the correct hardware solution that will be able to work within your system. That includes the power supply and the different sensing functionalities that are required. Now, not only are the hardware models going to be provided, but also the software platform library will be included to include the different building blocks for various different communication protocols that can be adapted to fit within the specific needs of the application. With this extensive library, it can help the user easily maintain the module performance, especially even as they're changing their device functionality as new versions are being developed within their own project. Now, as we've developed the IoT Gateway module, we've thought long and hard about what kinds of different applications can best utilize this technology. While thinking about that, we've looked to design a solution that can be adaptable towards various different applications, but we're also looking towards what sort of applications are going to be most benefited by this gateway module and what types of sensing are going to be needed in such a device. With all of that in mind, we are developing the Omron weather sensor. We're excited to introduce this product as the weather sensor module includes several different environmental sensing functions and communication all in a singular housing. The sensor features low power wireless technology, especially with the upcoming introduction of LoRa communication within the device. It features low power consumption, not only within the communication module, but also Omron's own proprietary technology that's incorporated into the sensing functions allow the product to operate well even in low power conditions. The sensor is also designed with low maintenance in mind. One of the biggest advantages that we offer is the sensors themselves that are included in the weather station. For rainfall and typical sensors that are employed on the market, it's using a tip bucket functionality to measure rainfall that includes moving parts. Also, in wind sensing, you're having an anemometer and a weather vane to gather the wind speed and the wind direction, respectively, that are also prone to getting stopped up by the dirt that's in the environment, and these moving parts can also break and wear down over time. With the Omron weather station, we're giving the easy to maintain advantage with our optical sensor for rainfall and our ultrasonic sensors for wind speed and wind direction. We also have designed the device to be able to operate well and protect the sensors from any harm from radiation in the temperature and humidity sensors, and also the design for it being able to work well even in dusty and dirty environments. The sensor all working in a singular package that you see pictured on the left-hand side of the slide makes it a very easy to install application that we've seen succeed in field testing around the country today. So the weather station itself, as I mentioned, includes seven different sensing functions: temperature, humidity, barometric pressure, light, wind speed, wind direction, and rainfall. The weather station is designed specifically for outdoor applications, especially in areas that are remote, that are requiring long-range data communication, and in areas that are looking for devices that can be low maintenance and easy to monitor over time. The low power wireless technology means that the module could transmit data easily at a low cost, either between various different weather station areas that the user is setting up, or towards the central digital devices so that the user is able to monitor their data remotely. The sensor is effective and able to give us real-time environment detection. We've been utilizing some of the technology that our engineers have been experienced in with some of our past products. Some of you who are familiar with the Omron product library may recognize the 2JCIE environment sensor and how that has helped in our development chain to get to the weather station. Our 2JCIE sensor is a USB version of an environment sensing solution that is already currently on the market. Our engineers' experience with this sort of environment sensing application helped us to create the best version of the weather station for more industrial outdoor applications. Omron has helped put together the weather station using the sensing technology that we've had experience in over the past years, as well as our development of the IoT module that we talked about just before. We've deployed sample sensors across testing at different Omron facilities and sites across the US and Canada. We see the one pictured on the right-hand side here at our own Omron office. The software dashboard developed for easy data management we have screenshotted below that can allow the user to easily monitor data on the fly and download and track the data for year-to-year monitoring. We've seen successful performance in field testing even in harsh conditions. However, we'll see the one outside our office being put through the ultimate test going through the Chicago winter. In conclusion, the Omron weather station with LoRa communication can be a key asset to several industries, including smart cities, agriculture, and oil and gas. We see a lot of benefit in rural and isolated application, as they'll have a stronger need for the long distance communication. Low bandwidth data communication is also key for simpler applications requiring lower maintenance. The interconnectivity potential, especially with the weather station and its ability to work with other potential IoT and LoRa sensors, allows for devices to work closely together in a wide area network. So we come to our last poll question. How crucial is LoRa for your next project? We'd like to hear from you whether LoRa is just something that you're considering, as it might be nice, but maybe you don't have plans for it in the immediate future, or if LoRa is critical and you're looking for a solution as fast as you can that can work well within the LoRa space. We'd like to hear from you and see if we can work with you on getting your next project off the ground. So lastly, we'll take a brief look into the future and also touch on some of the other products that we offer within Omron. For those of you who are not familiar with Omron DMS products, we provide solutions to develop product features essential to achieve carbon net neutrality in a digital society. Our division produces several different categories of components that can fit in a wide range of devices across various industries. Our switches include general purpose basic switches, trigger switches, dip switches, and keyboard and mouse switches. Our power relays include general purpose MOSFET, automotive, and solid state relays. Our connectors, D-sub, DIN connectors, MIL flat cable, and USB connectors, as well as our sensors and modules, including flow sensors, thermal sensors, optical sensing, and our OCal facial recognition technology. We have several different product offerings, and we encourage you to check out our website to learn a lot more about everything that we have to offer. As we continue development on these products, our engineers are always hard at work creating the next big thing. We encourage you to check out our Component Insider for the latest up-to-date news on all of our different product offerings at Omron. Thank you all very much. Again, my name is Cary Horan, Business Development Manager at Omron. If you have any questions, we have a brief question and answer session after this, where I am happy to answer any of your questions on what we've presented today. If you have any comments on any of our other products, you feel free to reach out to me directly at cary.horan@omron.com or to your local Omron representative. And to learn more about this and any more of our product offerings, please visit our website at components.omron.com. Thank you very much, and we'll hand it back to you.
All right. Thank you, Cary, for that great presentation. I'm really interested to follow the expansion of LoRa in the coming years. It's those long-range capabilities you talk about really just seem perfect for distributed IoT applications, as you highlighted. So we already have several good questions from our audience. I'll remind everyone that there's still time to submit questions to Cary. Cary, you ready to answer some questions?
Yes. Can you hear me?
Yeah. All right.
Right, great.
So talking to each other. That's good. All
Excellent.
right. First question is an interesting one. Is can LoRa be used for geolocation? Example by triangulation, and if yes, at what max distance?
So that's actually a great question. For geolocation, we have not done a lot of extensive research having multiple of our sensors in a singular field that are operating in that way. We do see that there is potential there in the ability for devices to connect with one another in terms of that two-way communication with LoRa. But in terms of geolocation, that's definitely something that we have talked about, but we have not done our extensive looking into that. It does seem like something that we would be able to handle with LoRa, but of course, like I said, something that we can continue to look into.
Very good. The next one's a kind of an obvious question, I guess, and I'm going to add to it. The question is, what is the cost of the weather station? And I guess related would be, what's the best way for people to get it if they're interested in getting their own?
Yep. So great question. We actually don't have the sensor officially released at this point. So the price point we are targeting at about $1,500 per unit. However, right now we do have several samples that are available, and if you are interested in getting your hand on one, if you feel free to reach out to me or your local OMRAM representative, we can happily provide one for testing if you'd like to do some evaluation on it. But once we get the final product out into mass production, then we'd be able to get some on the market and have an idea of the final cost.
Okay, so we're getting a sneak peek today. Awesome.
Yeah.
Next question is really about interoperability with other things that might interfere. The specific question is about like in villages, rural areas where the primary communication is probably going to be cell towers. But I think the question generically is a good one of how well does LoRa work in and around things like cell towers and other radio communication devices?
That's an excellent question. We have seen the ability for LoRa to work in both rural and very crowded areas. The fact that it's able to, again, using the spread spectrum modulation to transmit data across various different frequencies helps to minimize that sort of interference that's taking place. So there is a need for a separate sort of structure that is, or a special sort of structured network that is able to actually collect and transmit those LoRa signals. So there is going to just need to be ways for that signal to be transmitted. But in terms of interference, we have not seen a whole lot of problems either in rural or urban areas in Wi-Fi or cellular signals interfering with LoRa.
Excellent. Yeah, it's a good question, and certainly it's one I'm assuming the standards committee was working very hard to make sure that that was going to be taken care of. Okay, next question is, what is the meaning of open platform for LoRaWAN, and has the industry standardized on how LoRa devices communicate, or is there still work going on towards that goal?
There's definitely still work going on towards that goal. Also a great question. There is work towards a broad industry standardization, but also part of the beauty with LoRa is the ability for that platform to be built in several different ways. We've seen working in a lot of different industries, just in terms of how they're handling LoRa data transmission, whether it be in the energy sector or something more simple, just general basic environment data monitoring. There are different methodologies for how that LoRa signal is handled, and especially how that data is being transmitted across that space. The specific meaning of
yeah, I'm going to follow up on that.
Yeah.
Oh, go ahead. Yeah, I think you're going to answer the specific meaning of open platform. That's going to be my question. So go ahead.
Yeah, well, I was sort of not getting into that in terms of specifically for LoRaWAN. That is actually, so I am currently in touch with representatives from the LoRa Alliance and working with LoRaWAN and getting a lot more info on how that is specifically structured in that standardization. But the ability with open platform is currently the standardization is something that is, we've seen companies have it be a very easily approachable situation in terms of their own programming. But specifically the open platform for LoRa, that's something I'm still continuing to gather information on within the LoRa WAN Alliance.
Okay. Next audience questions is asking for some more information about the gateway device. How does it, in a remote field, make a connection to the cloud?
Excuse me. I'm sorry. So in remote areas, there will have to be some gateway structure or some structure that's able to transmit that data. So there is in a completely remote area where there is no structure around. I mean, obviously, with nothing to receive the signal, it's not able to transmit it effectively. But in these remote areas, again, using that spectrum modulation, getting the ability of transmitting that, projecting that data and transmitting over different frequencies is where we're able to get that much more extended distance that can reach in remote areas. We're looking at tens of miles that the signal is potentially able to reach. But eventually, it needs to have some sort of source, either a gateway or the final end source, a computer or whichever device that's actually collecting the data, at least within the range of the signal that's being projected. But with LoRa, the big advantage there is the ability for that signal to project from the gateway a much longer distance versus other traditional communication methods.
Okay. Next question is asking about, in cities, how do you extend the range of the wireless? And I guess ask on that, is this like kind of hopping network where you can transmit data from one to the next? It's sort of a mesh thing, or is it all to a central gateway?
There is, we have not specifically worked within mesh gateways, but there is the possibility within LoRa to build that mesh network. So that is certainly a way to sort of extend the range of LoRa in terms of distance. It's a little tricky within cities because the infrastructure, the crowded space, all the buildings is going to be a little bit limiting in terms of how quickly that data is going to be able to transmit. So it will have to come specifically to the application. There are a number of different ways. I mean, the signal can be boosted through other means, other gateways, nodes that are able to collect and then transmit that data a little bit more effectively. So yeah, there are a couple of ways. I think building in that mesh network could certainly help. But it is definitely a challenge in cities when you have so much that's potentially interfering with that signal.
Okay. Well, here's a good question. Are full data sheets available for the weather station?
So our full data sheets are in the process of that final publication. We do have the basic data sheets that are available. And for those who are interested, we'd be happy to provide that information. The full data sheets are right now going through our edits, and we have not fully published them just yet. But feel free. I will reach out to the person who asked this question and get them the info they need. And if anyone else is curious about getting data information, specifications on these products, please feel free to reach out.
Very good. This question is asking about weather station licensing being available to sell and use in India.
That is something that I will have to come back to that user on. As much as I work with our company, with applications all over the world, I only have as much familiarity as I can with different countries. So it's something that I'll have to reach out and follow up on. We do have Omron offices all over the globe. And that's certainly something that I think could be possible, but we'd be reaching out and talking a little bit more with that asker later on.
Okay. This question is asking if you've done any wide-scale application testing yet for the Omron weather station.
Yes, we have. I mentioned earlier in the presentation, we have a number of different setups that we have in different areas across the US with smaller applications. But in Japan, we actually have a current deployment of the weather station in mass product usage for a weather data collecting application. So we have a company that we're working with that has been purchasing a number of our weather stations and utilizing them in their weather research applications to very strong results. Now, in this case, they are using cellular data. So we are at least proving the effectiveness of the sensor performance. And then from that, we're looking to add in the different communication protocols such as Wi-Fi, LoRa. But we have seen how well the sensor is able to work gathering data year-round and across various different locations around Japan. But we're excited to continue bringing them over stateside.
Okay. So this question is asking is when do you expect the weather station to be released? And then what is the sensing range of the weather station?
We're looking to fully release next year for the weather station. But as we continue testing, we're seeing continued results, and if those results continue to be as positive as they are, we're looking to, of course, launch as soon as possible. And there's a second part to the question, and it left my screen. The sensing range. The range of the weather station. The communication method that we're utilizing, it's going to depend on that. But in terms of that's going to depend on the communication protocol that's being used. As we incorporate LoRa, we're hoping to up that to tens of miles. But using the cellular data, I think in remote areas, we're getting ranges of up to 2 or 3 miles in best case scenario. But that's, again, with just the cellular data. That's the current model of the weather station.
Okay. Our next question is asking about whether someone can test the functionality of the weather station today. And I think you've kind of answered this, but it's good to rehash that.
Yeah. So if you're looking to test it, like I said, we have a couple of samples in the field already. I've got a couple more that are coming my way that I'd love to get in the hands of other people and continue testing out in various different applications. So yeah, feel free to reach out if this is something that you're looking to get your hands on.
Okay. Will the station work on a private LoRa network?
Yeah. So while we incorporate LoRa, we're really just incorporating the communication protocol. Working on a private network, that is, going to be something that takes a little bit more of a unique setup. But with our engineers that have been working extensively, not only with the weather station, but within these different communication protocols, we can certainly offer the support to help you get going on that.
Okay. We have a follow-up question here. Some of the audience person is elaborating on their question about the sensing range. They want to know is how far can they sense parameters like temperature and humidity?
I see. So in terms of long-term performance, we have a number of the sensors that are in there are using our own technology that we have designed to work with low energy output, low energy requirements, and software that is able to keep the products working extensively throughout their lifespan. A number of our sensing products that are incorporated have a 5-year lifespan. In terms of long-term testing for the weather station itself, we've seen a lot of longevity for the individual products, but as we get into this more rigorous field testing, as it's exposed to the elements, we are seeing how long it's able to measure those parameters in the field. That said, as I said, we have the wide scale distribution on the weather data company out in Japan that's been testing out our sensors. And so those sensors have been out for several months at a time, and so far we have seen very favorable results there. It will certainly depend on the conditions. We know that there's a higher risk in very hot or very volatile weather applications. But our products, what I can say is that our products are designed to be ones that are long lasting, not just in terms of the structure, but in terms of the actual electromechanical performance. We strive to have products that are able to have as long a lifespan as possible as they're working in their applications.
Okay, then this question is asking if you're working at Omron to incorporate LoRa communication into any other products.
So absolutely. As I said, with our IoT module, that is something that we sort of developed as a foundation for where we're looking to go with some of these device and module solutions. The specific data that we're looking to collect is going to vary for all different kinds of applications, all different kinds of industries, whatever they're trying to do. So while we have specifically developed the weather station to work within to be incorporated with this LoRa technology, with the IoT module, that's going to give us the flexibility to have so many other different products that we can incorporate on something that's able to transmit that data effectively and cleanly. In terms of those final packages, those are always ones that we're continuously brainstorming, using something that is detecting thermal activity or using something that is detecting human motion. Those are all things that we are looking as potentials for incorporating with LoRa communication. But all that coming baseline from our IoT module is what's giving us a lot of flexibility to really try out as many different projects as we can and see what's going to really benefit and how effective we can make it with some of our products.
Okay. Okay, I'm not quite sure I'm following this question, but we'll give it a shot here. So,
I'm seeing the question. I can take, because I know this user had several different questions, and I'm happy to get in touch specifically, and we can have a good exchange as we.
Okay, take that one offline.
Yeah, for sure.
Yeah, that's excellent. Thank you. Before we wrap up here, we got a little time for people to submit some questions. Did you have any interesting, from the polls that you asked, anything that you saw that really interested you? I know for me, I saw that almost 50% of the people responded other for the industries. I'd love for them to throw into the Q&A right here what some of those other applications and industries you're working in. But how about you, Cary? Any other interesting takeaways from the polls?
That definitely jumped out at me. The massive other applications that people are looking for to potentially incorporate LoRa. So yeah, I'd love to hear about more applications and more people that are interested and the different types of industries that people are involved with, because beyond our products here, we have so many different products that we're so many different products that we produce and so many different industries that we love to get involved with. I did notice it fairly interesting, and it does make a lot of sense, where a lot of people are just learning about LoRa and currently don't have as strong of a need for it currently. And what I hope, and as we continue communications, and I'll of course reach out to those who are either just curious or the couple of people who also said that LoRa is critical. I hope that this webinar has inspired maybe taking a closer look at LoRa and taking a closer look at some of these different innovations that are coming with it. And we'd love to inspire people to continue thinking of projects and continue considering Omron for assistance on their next big thing.
Yeah, absolutely. It is, some people have already recognized that it's just kind of the perfect solution for some of these long distance, low power applications, but it's still relatively new. So that it's great that you guys are coming here and sharing the information and teaching us all about it, so we can look at a lot of applications. We did get another question come in. It's asking if you use more power, can you get a longer range for the LoRa modules?
It's certainly possible. There are limitations there, but with higher power supply, you're of course having the device work a little bit harder, have a little bit energy. It's hard to say. I don't have the information in front of me for how direct that relationship is by incorporating a higher power supply, how much that signal does boost. But that's a very good question, and it's something I can look into.
And I would assume that some of that is limited by the standardization limits of how much RF power you can output in those bands and to minimize interference. But there might be also options for directional antennas. So Cary, thanks for that great presentation, the Q&A. Any last thing you want to elaborate on or make sure the audience takes away from the session before we close up for today?
The only thing I want to say is whether you are fascinated by this topic here, or if there's anything else that you're curious about what Omron is doing, if there's something that you're getting involved with and you've heard about Omron or you've heard about different technology and you want to see if we'd be able to help you, please reach out to myself or reach out to your local Omron rep. Take a look at our website. We continue to have various webinars, I believe every month, just about. So we're always coming out with new technologies, getting involved in very new applications, and really looking to innovate into various new products and various new methods of communication, for instance. So please don't hesitate to reach out. We'd love to get in touch with you and see what kind of help we'd be able to provide.
Excellent. Well, thanks for your time. Hey, audience, if you want to download Cary's presentation, you can get that up in the handouts tab before we close everything up for the day. In just a moment, you will be redirected to Omron's page on All About Circuits, where you'll be able to view this session on demand and check out other great Omron resources that are readily available. So thanks, Cary, for joining us.
Thank you.
Yeah, and we look forward to seeing everyone again at another live session again soon.